Okay, YouTube, in this video we're going to define a unit vector and discuss how you can find a unit vector that would be going in the same direction as a given vector, but only one unit in length, okay? So we're going to say a unit vector, we're going to define this as some vector u here in this instance, but we say it is a unit vector if and only if it equals the reciprocal of its magnitude times the actual vector here. So the things I want to point out are, first of all, these. This reciprocal of the magnitude, reciprocal of the length, that is a scalar, okay? And what we're doing is we're taking a scalar times a vector, and so we get a new vector. And so anytime you take a vector times a scalar, that is, if this was u, and we say, well, what's 2u? What we're doing is we're modifying the length of that vector, but it would be u plus another u here. This would be 2u, but it wouldn't change its direction. So our goal in this case is going to be able to find what could I take any vector u times in order to get its magnitude to be equal to 1. And so we would say that u, if we were to find its length, okay, that is this length right here, we call this the magnitude of u. And we were to multiply it by its reciprocal, we would get a vector of length 1, because essentially anything times its reciprocal is 1. So in other words, if u had a length of 5, let's just say that, the magnitude of u is 5. If we were to take u now times 1/5, it would be 1/5 of its original length, okay? And its original length was 5, so we would say that now it is a vector of length 1, all right? So we say, note that u is a scalar multiple of v, but essentially this unit vector u is really just this vector v times the reciprocal here of the v's magnitude. So it's scalar multiple of v. We're just scaling its length down. And we say the vector u has a magnitude of 1 and the same direction as v. So let's go ahead and take a look at an example. What if we had a vector, we'll keep it pretty simple here, and its component form was 3, 4. That is, from the origin it goes right 3, 1, 2, 3, and up 4. And it terminates there. So starting at the origin, goes out to here, and here is our vector, and this is our vector v. Okay. What we want to do is we want to come up with a new vector u that is going in the same direction as v, but has 1 as its magnitude instead of a magnitude of what it currently has. So what I want to do really quickly here is I want to find the magnitude of this v right here. And you might recognize that this is a 3, 4, 5 triangle, but to find the magnitude of v, this is the first thing we're going to need to do here in order to find our unit vector, is find the length of the original vector, which in this case is the square root of 3 squared plus 4 squared, or the sum of the squares of its components, the square root of that. So we get 9 plus 16, this is the square root of 25. And since we're talking about a length here, we're going to say that it's 5. So the magnitude of the original vector v is 5. So if we want to find a new vector, this is our unit vector, a vector with a length of just 1 unit. We say that it is some vector u, and by definition u is equal to the reciprocal of v, the magnitude of v, times v itself. So we get this now, 1/5 of v. Well, if this has a length of 5 to begin with, then 1/5 of that would be a length of 1, and it would go in the same direction. So by using this definition, we could just say that it's 1/5 times the v vector initially, which was 3, 4. And we would say that we get some new vector now, distributing that through, we would get 3/5, 4/5. So any vector that would terminate at the point 3/5, 4/5 would have the same direction as the initial vector v, but a fifth of the length itself. So in general, to find a unit vector, you find the magnitude of the vector, and then take that vector times the reciprocal of its magnitude, which should scale it down to a length of 1. Cheers.